let me work out an example of inverses of matrices. In here, I already worked out the reduced echelon form to save some time, so let me go over this problem. Suppose that we have the linear transformation t of x, y, z given by this expression, x plus 2z, x minus 2y plus z, and 2x minus 2y plus z. And suppose that we want to find out what is the inverse for that transformation. So what we need to do is we can write down the matrix representation for this transformation just by reading the columns of the expression that we have over here. In other words, just by reading the coefficients for x, y, and z, we can write down the matrix representation for this linear transformation. Now, in order to find the inverse for this, what we can do is just to compute the reduced echelon form for this matrix with the augmented identity next to it, which means what I have here in green. I can write down the matrix representation for the linear transformation and then augmented that with the identity matrix. And that's what we have in here. We have the original matrix on the left-hand side and the identity on the right-hand side. So the strategy is to compute the reduced echelon form on the left side, but to reproduce all the steps on the right-hand side. And then whatever we have on the right-hand side is going to be our inverse. In some sense, what we're doing is we're moving t to the other side, and then whenever we move it to the other side, it would get as t inverse. That's the basic idea. So in here, what I did was to work out the reduced echelon form. We have worked echelon forms a lot of times now, so I don't want to go over this. You can also use a calculator for that. And you can also pause this and check each of the steps. But in the end, we end up with the reduced echelon form on the left-hand side. That's when I stop working. And then whatever I end up with on the right-hand side, that's going to be my inverse. So in this case, what I end up with is 0, negative 1, 1, a quarter, negative 3/4, 1/4, 1/2, 1/2, negative 1/2. And that would be the matrix representation for that linear transformation that is given up here. And if I have that matrix representation, I can go back to the actual coordinates if you wish, just by multiplying that matrix with the vector x, y, z. So that would give me the first row to be just negative y plus z, a quarter x minus 3/4 y plus a quarter z, and 1/2 x plus 1/2 y minus 1/2 z. So that is the expression of the inverse of the original linear transformation that I had.